So we're going to take a look at these triangles again, the ones that haven't been drawn for us, and solve them. In other words, that means finding all three angles and all three sides. And before I start doing any calculations, I'm going to make a sketch to help me make some predictions. So I'm going to start by making my horizontal line. I'm going to call this angle A, and I'm going to draw in 20 degrees as a start. So this is 45, diagonally, the diagonal there, and I know 20 degrees is about half of that. So I'm only going to go up half that much, and there's my 20 degrees. And I'm going to make this 20 centimeters long. And this is 20 degrees. Now the next step is so I've drawn in this and I've drawn in this. Now I'm going to draw the side that's opposite angle A, which is 12 centimeters. And that is shorter than 20 centimeters. But how does it compare to the height? So I'm going to find, well, what's the height? The height is the 20 times the sine of 20 degrees. And where does that come from? That comes from in the sk2, because the sine of angle A is the opposite over the hypotenuse. So that means the sine of 20 degrees is the height. In this case, the height is the opposite side over the hypotenuse, which is 20. And so if I multiply the 20 across, I get the height equals 20 sine 20 degrees. So that's a review of what we've already done once before in the previous skill, and I can tell that the height is 6.8 centimeters. So that means that this is definitely longer than the height. And so it's going to mean that I can have to swing it out to make it fit, either in this direction or in this direction. There we go. So I'm expecting two different triangles for this one. This here is 12 centimeters, 12 centimeters. So I've got two triangles. Here's my first one, and there's my second one. So we've established that there's going to be two options, two triangles for this situation, and I've drawn out the two possibilities as a rough sketch here, and I need to solve the triangle. So in other words, find all the angles and all the sides. And I'm going to do this for the two triangles. I'm going to start with the one on the right. I'm going to start by taking a look and saying, hey, I've got this angle in its opposite side, which means I can use the sine law to find out this missing angle B. So the sine of B over 20, because 20 is the opposite, centimeters is the opposite to angle B, is equal to the sine of 20 degrees over 12. Now remember, I've got to get B all by itself, so I'm going to multiply both sides by 20. And it cancels on this side, and I end up with the sine of B equals 20 times the sine of 20 degrees. And I pick up my calculator, and I can calculate the right side here to be 0.57. Now to get B all by itself, I've got to get rid of the sine, so I take the inverse sine of both sides. So if I take the inverse sine of 0.57, I get an angle of 34.8 degrees. So that means that this here is 34.8 degrees. We're getting closer. Next step, I want to find all the angles and all the sides. I'm going to try and find angle C. But there's 180 degrees in a triangle, so angle C has to equal 180 degrees minus the 20 degrees minus the 34.8 degrees, which equals 125.2 degrees. So I'm getting closer. I have two sides and all three angles. So the only thing left here is now little c, capital C, we know is 125.2. So again, I'm going to use the sine law to calculate that. And this time I don't know little c, so I'm going to put that on top. Sine capital C is 125.2 equals, now I could use either of the pairs, the angle B information or the angle A information. I'm going to choose to use the angle A because that was given in the problem. So C equals 12 times the sine of 125.2 degrees, because I'm going to multiply both sides by 125 degrees, 0.2, divided by the sine of 20. So C in this case is, I'm picking up my calculator here, so sorry for the delay, is 28.6 centimeters. So this is 28.6 centimeters. And then I double check, does that make sense? This is longer than this, and sure, my diagram shows it should be longer. So there's just a quick visual check. Now I've run out of room and I still need to talk about the second option, which I will do in a second. So what's with the two triangles? How did we get that? Well, if we think back to solving sine equations from very early on in this unit, if I asked you to solve the sine of b equals 0.57, and you want to do it anywhere between, where b can be anywhere between 0 and 360 degrees, how many answers can I have? Well, we know from the CAST rule, or all scientists take chemistry, that the sign is going to be positive in this quadrant and in this quadrant. So if I take the inverse sine now of 0.57, I get angle B equals 34.8 degrees. So that's this angle. But remember, there is a second option. It's sitting right here with the same reference angle. So that second option, the answer is actually 180 degrees minus 34.8 degrees, which is 145.2 degrees. So there are actually two solutions to this single sine equation. Now, how does that fit into our problem? So remember, we solved the triangle once and found all these beautiful sides and angles. And part of that process was setting up this sine rule. Remember, the sine of 20 degrees over 12 was equal to the sine of b over little b, which is 20. And we solved that and got to this stage, sine of b is equal to 0.57. And we came up with an answer of 34.8 degrees. But there is a second option, and the second option we never considered in the last run through this triangle. Angle B could also be 145.2 degrees. And if we take a look at this diagram, this is 145.2 degrees. So that's how we get the second triangle. It is related to the sine law, and that there are two solutions to when you take the inverse sine law, is inverse sine of a number. Once we have established the second possibility for B, we proceed as normal. So we've got this triangle, there's 180 degrees in it, so angle C has to equal 180 degrees minus 20 minus 145.2 degrees. So we then know that angle C is 14.8 degrees. And then finally, to find out what C is, we can use the sine law again. So the sine of 14.8 degrees, C over the sine of, so here's little c, this pair here is equal to 12 over the sine of 20 degrees. And calculating with C, I'm going to multiply both sides by sine 14.8. What I do to one side, I do the other. On this side it cancels, so I end up with 12 sine of 14.8 divided by the sine of 20. And quickly picking up my calculator here. I get 8.96 or 8.96, which I'm going to round to 9 centimeters. So this here is 9 centimeters. Does that make sense? Yes, it's definitely smaller than this, which we predicted from our diagram. And it looks like by our really rough sketch, it should also be smaller than 12. So it looks like I'm on the right track. This is called the ambiguous case of the sine law because you've got two options for a single set of starting information. So just to be clear, when is there a possibility of getting two triangles? First of all, when the triangle is not drawn out for you. In other words, when you have a list of values that you are given. So if you actually have to draw out the triangle yourself, there's a possibility that there might be more than one option. The other condition is that the triangle information that you are given is SSA. Now what that means is that you know a side, another side, and an angle that's not connected, it's not in between. So you know this side, say that's 20, you know this is 12, and you know this was 20 degrees in the question we did. So this angle here is not in between the two sides we know. So that's angle, side, side. So you can see that spells as, which mathematicians try to avoid swearing, so we reverse it, SSA. Anyway, that's the conditions under which the sine law might be ambiguous.